So as we can see here by the course syllabus, this is the second lecture for 4303. And for anyone in the class, the links to watch the videos are here in the course spreadsheet. You can also download the slides, watch the video on Twitch or on YouTube, or you can load the playlist and watch all the videos if you want to. So for those of you who weren't here last time, today we're going to be going into an intro to C++. So this course is going to be taught in C++ as the main programming language, along with the SFML graphics library. Now, you won't have to know a lot about the SFML graphics library because all the user interfaces and stuff I've already done for you. But just in case you didn't take Computer Science 4300 with me and you're completely new to C++, I did want to go over the very, very basics to C++. And again, just to mention, so the other course that I teach, the Intro to Game Programming course, so 4300 here, if you click the link to that, you'll be taken to the playlist for that course. And if you want to, so lectures 3 and 4 of that course go into some more advanced topics in C++ and how to use the SFML programming language. So if you ever find yourself just craving more knowledge about C++, which any good programmer should know a little bit about C++, please feel free to go watch those lectures. But as I said, this course isn't as hardcore C++ as that one, so I just left those lectures out of it. But what I will be doing today is going over some slides for an intro to C++, and then after the slides, I'll be giving a live programming demo. If you did 4300, this is almost the exact same lecture as the second lecture from that course, but I definitely want to do it for both courses and probably include a little bit more info than was in the second lecture for that course. I've also got a kitten asleep behind me, so if she wakes up, maybe she'll make an appearance on the stream today. But I don't want to wake her up just yet. So let's bring up the slides, and we'll go through the slides, and then we'll do the live coding, and I'll hope that I don't screw up the live coding too badly. All right, come on, slides. Let's start playing. Cool. All right, so this is lecture number 2, and we're going to be going over the C++ programming language, a little bit of the history of it and the basics, and then after the slides, we're going to be going through some programming examples, pretty much all that you'll need to know for the course, because this course really is about the techniques, but not like hardcore. It's about the algorithmic techniques, not about all the language features of C++. Someone in the chat just asked, Prismata AI in the syllabus? Yes, there will be Prismata AI in this course later on, so stay tuned for that. First of all, I wanted to mention these really excellent C++ references. As I said, I didn't want to have people having to spend hundreds of dollars on textbooks or anything for this course. So what I have instead is a bunch of online resources which will suit you just fine. So rather than having to buy books, there's a really excellent tutorial here at learncpp.com. So the laser pointer is showing up there. So if you go to learncpp.com, really great tutorial step by step. If you're absolutely new to C++, please go try that out. There's also CPP Reference, which is sort of the go-to online reference for the libraries and functionalities that are built into C++. Also, there's cplus.com, and there's tutorials there and more documentation for C++. So, if you ever Google like file reading in C++, you'll probably go to one of these 3 websites, or Stack Overflow, of course. So, what is C++? Of course, you all know that it's a programming language. And C++ is a high-level programming language, so not as high level as something like Python, but it's higher level than something like C. It's designed, it focuses on run speed and functionality. So C++ is a language in which you can create very, very fast programs, but also very, very slow programs if you don't be careful. And it also has a ton of functionality built into the standard template library, which we'll be going into a little bit at the end of the lecture. C++ is a compiled language, unlike something like Python. Okay, C++ is sort of a mid to high level programming language, so I kind of contradicted myself here. If we think high level, we're thinking something like Python. If we think low level, we're thinking something like assembly language, right? And so C++ is somewhere in between, but you can use C++ to write low level C type code, okay? So you can directly manipulate memory, bits and bytes in RAM. It's a very, very powerful programming language that lets you do mid-level and high-level things, depending on the languages that you're using. So some of the advantages of C++, first of all, it's extremely widely supported and widely used, so you're going to be able to find help for almost anything online. There's many libraries available online as well. So for example, we're going to be using the SFML library, which is the Simple and Fast Multimedia Library, which will let us do things like set up a window, draw some things to the screen, and record mouse movement and keyboard inputs and stuff really, really easily. The resulting code of C++ can be really fast if you write it correctly. Hopefully we'll be writing it correctly this term. And the syntax is very, very similar to Java. It's very similar to C. It's kind of similar to Python, but not really. But you'll be able to read C++ code. It's not going to be that difficult if you've learned another language like Java. C++ programmers can get hired. There's lots of jobs available for C++ because it's such a great language. The code is highly customizable, meaning you can do almost anything with it, and we'll maybe get into some examples of that later. Some disadvantages of C++, as I saw in the chat, there was a comment on this, is that it is easy to write unsafe code or code that crashes, okay? And you must manage your own memory. Now, it turns out that we won't have to really be dealing with any memory management in this course. The reasons for that we'll get into later. But in C++, especially older versions of C++, like C++ 98 and before, it was very, very easy to write unsafe code. So the analogy of C++ that I like to use is that it's almost like driving, if you have to go to the store to get milk, it's almost like driving a Formula 1 car to go get milk, right? It's kind of easy to crash the car, but if you do it correctly, you can get milk really, really fast. However, more modern versions of C++, and we'll be using C++ 17 in this course, make it much, much safer to write really, really powerful code. So the more modern versions of C++ that you'll see and that we'll be using in this course, it's actually kind of difficult to write unsafe code because the standard template library gives us all of the tools that we'll need to be able to write really safe and really fast code. Notoriously, C++ compiler errors can be really hard to interpret. And so we're not going to be getting into a lot of complex things like templates or metaprogramming in this course. But traditionally, C++ compiler errors can definitely have some cryptography skills to interpret. So the general rule is when you see an error, ignore everything except the first error, okay? Because the first error is usually the cause of all the other errors and creates really complex error messages. So go to the first error, see what that says, try and solve that, and then go to the next one. The syntax can be a little bit confusing in C++, but in this course, like I said, we're not getting into a ton of the syntax-heavy stuff, so it shouldn't be too bad. And also, because C++ is so customizable, it can be actually really hard to read other people's code. And that's because they could have like custom definitions, operator overloading. Like in C++, you can almost make one line of code do 10 different things, right? And so if someone has written unsafe code or really customized code, it can be actually really difficult to read that code. In my courses, I try and give you as vanilla C++ as possible so that it is actually really easy to read it. So, but in general, it can be hard to read other people's code if they've gone a little bit too crazy with the with the customizable code. I don't know why I forgot to take this out. This is not a disadvantage of C++. It's based on the C programming language. That's not supposed to be in this slide. Okay. I think it was supposed to be here, actually. So C++ is based on the C programming language, which was created by Dennis Ritchie of Bell Labs in the 1970s. C is available on pretty much any platform possible, right? Your toaster is probably running C code at some point. It's a procedural, low to mid-level programming language. There is no object-oriented programming in C. You can kind of mimic some object-oriented programming in C, but there is no inheritance or polymorphism built into C, which there is in C++. C is very popular for operating systems, for system software, for drivers, embedded software, all that kind of stuff. And it greatly, greatly influenced the development of C++. So, C++ was created by Bjarne Strusup of Bell Labs, and originally, referred to as C with classes back in the early 1980s. C++ is a procedural superset of C. And what that means is, and now there's always going to be C++ purists out there who say that C++ is not a superset of C, but for our practical purposes, okay, 99% of the time, any C program will compile in C++, okay? Now, there are exceptions. You can write C programs that use obscure functionality that will not compile in C++, but for the most part, the entirety of C is contained in C++, okay? But don't come after me because I said that. It's practically true, but not theoretically true. C++ supports object-oriented programming, so it has full polymorphism and objects and classes. And it also supports generics in the form of templates, but we will not be getting into templates in this course. It maintains the efficiency of C if you're careful. And it's very, very popular in video game development because it has object-oriented features, it has generics, and it's very fast, which makes it a great language for programming video games. And C++ heavily influenced the development of other languages such as C# and Java. So if you know those languages, some things in C++ will be very familiar to you. I like to always say some quotations about C++ because it's kind of, I don't know, other than politics and religion, C++ is probably the most debated thing that I know of. So some quotations about C++. Writing in C or C++ is like running a chainsaw with all the safety guards removed, right? So you can shoot yourself in the foot, but in C++, in comparison to C, it's harder to shoot yourself in the foot, but when you do, you blow your whole leg off, right? So C++ is a little bit safer than C, but if you do make a mistake, it can be pretty disastrous. So the person who coined the term object-oriented, I can't remember who that was, said, actually, I made up the term object-oriented, and I can tell you that I did not have C++ in mind. Someone else says, C++ is an abomination. Everything was wrong with it in every way, so I really tried to avoid using that as much as I could and do everything in C at Netscape. So these are quotes about older versions of C++, but I always like to throw them in there because they're just kind of funny to reminisce in and think about. And of course, there's this really famous quote here from Linus Torvalds, who, if you know anything about him, he does not like the C++ programming language. And so someone wrote on this forum back in 2007 about the Git source code, said, when I first look at the Git source code, two things struck me as odd. Pure C as opposed to C++. No idea why. Please don't talk about portability. It's BS. And then, of course, Linus responded, you are full of bullshit. C++ is a horrible language. It's made more horrible by the fact that a lot of substandard programmers use it to the point where it's much, much easier to generate total and other crap with it. Quite frankly, even if the choice of C were to do nothing but keep the C++ programmers out, then it would be a huge reason to use C, okay? So someone just asked in the chat, Linus Torvalds, was he the creator of Linux? So he wrote the Linux kernel, yes. But I'm not going to get into the Stallman memes and talk about GNU and Linux and all that kind of stuff. But yeah. Okay, so now let's talk about C++ versions, because there are different versions of C++, and they all have very different features, okay? So C++ first appeared in the early 80s. The first standardized version that I began with was C++ 98, And C++ 98 was the standard until C++ 11 came out. So it was 13 years of writing things that were, before C++ 11, it was kind of bullshit. There was a lot of stuff in C++ that was really, really annoying. But C++ 11 had a ton of quality of life features that were added to it and made it much easier to write safer code. C++ 14, 17, and eventually 20. I don't use 20 yet. In this course, we will be using C++ 17, but we'll be using a couple of C++ 17 features, but the cool thing about C++ is that for 99.99% of things, it's all backwards compatible. So if you have C++ 98 code, that will compile in C++ 17. It's just that C++ 17 will have some nicer features that will allow us to do things in easier ways than if we didn't use it. So we will be using C++ 17 in this course. It has nice new functionality over C++ 98, and when you compile your C++ program, in order to tell it, hey, this use C++ 17 features, you can put in the -standard equals C++ 17 flag. All right. So, some properties of C++. C++ is statically typed. So variables are defined before the use of the variables, okay? So unlike something like Python, or I'll get into that in a second. So this means that if we want to declare a variable, okay, we have int year equals 2018. So we have to declare the type of a variable statically typed. Java and C are also statically typed, and the variable types are defined at compile time. So it's not dynamically typed like C++, like Python, for example. So in Python, we can have a variable that's assigned to any type, and they can be defined at runtime, and they can be overwritten with different types and all sorts of things, okay? So it's a statically typed language, but I'm sure you're probably familiar with that already. So here is going to be, the canonical first program where we print out hello world. So let's walk through this example of hello world. So here we have include IOStream. So this is like your import commands in Java or in Python, where we're going to use a specific library, so we have to include that library. Every C++ program is going to have a main function, and that's going to take in some arguments, and we'll talk about that in a minute. Then we're going to print out hello world, and we're going to return 0. Okay, so this is our first hello world program, and we're going to do this later in a live coding session, but for now, let's just walk through each line of this program, and we'll explain what each line is doing. So, this first line, include IOStream. The first line is called a preprocessor directive, and we'll get into the preprocessor later, but essentially what it does is it's used to include a C++ library so we can use the functions from that library. Okay, so if you've used Java and is Java include or import? I can never remember. But in Java, if you want to use a vector, you've got to include the vector, right? So if you want to use IO streams, which are how we get input from the user from the console and print things to the console, then you have to include IO stream, which is the library that lets us do that. Okay. So this particular library, IOStream, is input-output stream, and it's used for input and output streams, and it allows us to use standard cout to print things to the console. Okay. So now we have the int main, int argc char star argv brackets. What the hell does that mean? Well, first of all, each C++ program must have a main function. So the main function is run when the program starts. Just like programming languages like C or Java, the contents of the function are enclosed in curly braces. The main function has an int return type, and it has two arguments that are passed in. One is an integer called argc, or argument count, and that's the number of arguments that are passed in via the command line, okay? So for example, if we write a program and we want it to be able to take like a file name or an integer or something like that, so we could run our program like my program and then 5 or Dave or something like that, this is where those things are contained. And argv is an array of string or character array arguments, okay? So this is very similar to Java's main string args. So you've all seen public static void main string args. So this string args here is essentially this variable right here. Now, the only difference being that raw C strings or raw C arrays, they do not contain the length of the array within the array itself. And so we have to have this second variable here, which is the count of the number of things in that array. So the next line, and my face is covering this up, so let me move that. The next line in the program is standard cout hello world. All right. So this prints the string hello world with a Newline character. So what this means is standard, or std as some people say, I use standard. std is a namespace, and we'll talk about namespaces a bit later. And that namespace contains the cout variable, which is an output stream. In C++, a lot of different streams use this operator, the double triangular operator. I call that the pipe operator. And so what you can think is it takes this string here and it pipes it into standard out. And this can be used to print any base C++ type. So if you want to print a string or an int or a double or a float, that can be just sent into cout and that will be printed. Also, each C++ variable or line, each statement must end in a semicolon, and C++ is indeed case sensitive, okay? The next line is return 0. So main has a return type of int, and you return a 0 if the program ran normally to a normal end without any crashes. And this return value is used by other programs to detect errors in your program's running, right? So if another program has to run your program for some reason, it wants to know if there was an error. So if there was an error in your program, you would return something else other than a 0, okay? And the program will compile and run without return 0, but it is highly recommended that you actually use return 0, okay? Just put it in there, and if you have an error somewhere else, you can return another error code. Now, of course, everyone in my course is going to write perfect programs that will never crash or never return any sort of error, but so return 0 will be fine for you guys, right? Okay. All right. Talking about white space now. So for the most part, in C++, white space doesn't matter, okay? There are things like you can't split a string over 2 separate lines, okay? But you can have like standard cout hello world. That is the same as standard cout with a bunch of spaces or tabs and then the pipe and then hello world. You could have it not begin at the beginning of a line. You could even have standard cout and then on the next line, the piping operator, okay? So white space does, for the most part, doesn't matter, but we still want things to look pretty, and we're going to have a style that we stick to in this course, which I'll talk about later. Also, for functions, you can put the brackets kind of wherever you want, and we'll talk about that a little bit more later. Here are the exceptions to white spaces, okay? You can't start one string here and end it on the next line, okay? If you do that, you have to put 2 forward slashes here. Also, you cannot have a comment be separated by 2 lines. And so this, if you start the comment here, the following lines would not be part of that comment, all right? And there's more on learncpp.com. There are more examples of this where white space matters and where it doesn't. Okay? C++ Indentation Embraces. If you came from Java or JavaScript, you are probably, and a lot of C++ people do this as well. This is called the K&R style and variants of K&R style, which declare something and then have a bracket on the same line, and later on they close a bracket down here. For me, when I write C++, I actually use the Allman style of indenting, and so all of you will have to use the Allman style of indenting. And it turns out that, honestly, after switching to Allman, and this is, of course, it's a religious debate, but, at some point you'll have a boss, and that boss will tell you, what sort of style your company is going to be using. And so the company of this course is going to be using the almond style. And the almond style is when you start the bracket on the next line and you end it down here. Now, I find it a bit easier to use almond style because, no, I'm not saying almond style. Thank you, Twitch chat. It's almond style. I find it easier because you can visually line up where code blocks begin and end with this, okay? Now, really quickly, the standard template library, this is where you get a lot of functionality that we're going to use in our programs. So the standard library, or the STL, it's a collection of classes and functions that are available within the C++ programming language. Here's some examples of functionality that's there. So you can have strings, input, output, streams, files, containers like vector, set, and map, container functionality like filling something, copying it, erasing it, algorithms, you can sort, you can have min and max functionality, lots of math functionality as well. So all of that is in the standard library. You must include whatever you want in the standard library in order to use it. It's referenced via the standard : namespace, and what a namespace is a namespace just encapsulates some sort of code. So if you're writing a library like the standard library, let's say I wanted to write the Dave library, and so the Dave library has a bunch of variables, it has a bunch of functions. What I can do is I can wrap all of that stuff in what's called a namespace. So I can say namespace Dave and then open brace, and anything in here until the closing brace of that namespace has to be referenced via the Dave namespace. And the way that you do that is you say Dave : Ivar, okay? So this means that for standard cout, somewhere in the standard namespace, there's a cout variable, which when you pipe stuff into it, it prints it to the standard library. So some examples of things in the standard library are standard string, standard vector, and standard map. And we'll be using some of those in this course. C++ source code. Program code that we will be writing in this course for C++ is written into .cpp files. So for example, we will have a main.cpp file in each of our assignments that contains the main function that's going to be run. In other projects and online, you may see people write C++ code in a .C file, in a .CPP file. As you all know, the extension doesn't really matter. It's just a naming convention. And so in this course, we're going to be using .cpp. And the CPP code is used for function and class definitions. Okay, and we'll get into this in a little bit. There's also header files. So header files are written into .h files. Some examples might be math.h or myclass.h, and those are used for function and class declarations. We will get into a little bit later in the live programming, we'll talk about declarations versus definitions, but we won't get into that now. And when I introduce the first assignment next class, you'll see some good examples of header files versus CPP files. All right, so how do we compile C++ programs? Well, first of all, you need a compiler, right? So C++ programs are compiled into binary executable files that are run directly by the CPU. So unlike Java, which you compile a Java program into bytecode that's run by a virtual machine, in C++ you are compiling it directly to machine code that's run by the CPU. There's no interpreter like in Python, and this means that ideally, if you've designed a language correctly, if you are compiling your program into binary executable files, then it should run faster, okay? But it's usually at the price of lower level programming. But what we'll see in this course is that we're using pretty high level programming to accomplish what we want. And there are many different C++ compilers for different operating systems. So for example, if you're using Windows, we're going to be using Visual Studio for Windows in this. Visual Studio is both an IDE and a compiler. It has a compiler built in. That's really convenient for you because within the IDE, you're just going to click compile and it'll run. And we'll talk about Visual Studio in the next assignment or the next lecture. Also for Windows, there's MinGW, which is kind of a standalone compiler that you would use via the console, but you're not using that. Yeah, so also please keep in mind that Visual Studio is not Visual Studio Code. I have posted on D2L the difference between those, but Visual Studio Code is essentially a really fancy text editor that allows you to integrate tools into it. But Visual Studio is a fully fledged IDE with a debugger and a compiler, etc. So it's just really unfortunate that they're named the same. If you're on Linux or Mac, you're probably going to be using either the G++, so the GCC compiler for C++, or the Clang compiler for C++. For Linux and Mac, I have given you a make file, and all you got to do is type make, and it will use GCC to compile that. All the instructions are available on the assignments part of the website. Okay, so how does a C++ program get compiled? Well, we're going to move this over here so you can see all of it. But essentially, the first thing that happens is the source and header files are run through the preprocessor. Okay, so you've got some source code here. It says .c because I took this from a lecture on C, and then you've got header files. Those files are run through the preprocessor, and you can have errors at the preprocessor level. So for example, if you tried to include a file that doesn't exist, then that will stop execution of compilation at the preprocessor level, and it will say, hey, that file doesn't exist. So it will either stop if there's errors, or it will expand the source file into a single file that's run through the compiler. Then you're going to compile your source code, and then it'll stop if there are any syntax errors at the compiler level. So for example, if instead of int you typed INTT or something like that, that's a compiler level error. If it's compiled correctly, it will be compiled into an object file. So every CPP file will get its own object.o file. And then along with any libraries, your object files and the libraries get linked together. So there's a linker step. It will stop if there are linker errors. So for example, if you told it to include an object file that doesn't exist, it will stop at this point. But if all of this works correctly, then you will have an executable file that you can run. All right, that's what I just said, and now there's slides for it. There are several popular compilers. So for Linux and Mac, there's the GNU C++ compiler, there's Clang. For Windows, there's Visual Studio and MinGW. Officially, this course, we're going to be using the GNU C++ compiler. Oh, sorry, don't listen to that. I'm going to edit that out right now. Oh, crap, 1 second. I'm editing that out. Pretend you didn't read that. All right. So Visual Studio, or VS, does the same thing behind the scenes, and its project file hides a lot of the details. So it's still important, though, to know this entire process and the command line steps to go through everything else. Okay. C++ libraries, or compiling, sorry. So we have a program written in myprogram.c. You're going to compile out the code into an executable. So if you just type g++ myprogram.c, it will actually do all of those steps for you, okay? There's not one command for the preprocessor and one command for the compilation and one command for the link. It'll do it all for you if you want it to. So if you just type in g++ myprogram.c, it will by default produce an executable file called a.out. So to specify the executable name, you can say g++ myprogram.c-o for output myprogram. And then you can run the program with /myprogram. So this is if you're doing it with the command line. If you're doing it with Visual Studio, you just hit compile and run. It'll produce the executable file and it will run it for you. If you want to view the results of the preprocessor, you can do that with -e. So you can say g++ -e myprogram.c and then pipe that into a file. And then if you want to compile it into a standalone object file, you can do that with the -c command. And then you can link together multiple object files with the with G++ and specifying the multiple object files, okay? This is done for you by the makefile that we've created. If you want to go more into details of that, please go look up more on the C++ compilation process. It's not a super important part of this course because it'll just work for us. Okie dokie. So multiple files can be compiled in one step if you want to, and you can just say, hey, compile all of my C++ files just by saying star.cpp if you want to. That'll do all of it. However, linking is much faster than compiling. So typically we do not want to compile all of our C++ files every time. And so what we would want to do is only compile files that have changed since the last time we've done something. And so, for example, if a C++ file has changed, then we compile it and then just link together the ones that have changed. This is done with a makefile that I've included for you, but it's automatically done by Visual Studio. Okay. And a lot of this, I know I'm going through this quickly, it's because I want to get to the live coding, and the live coding will explain a bunch of this for us. The preprocessor, what that does is it runs all of the specific preprocessor directives. So there are a bunch of different things that the preprocessor can do. One is include a library. Another is include a specific file. And another thing we can do are defines. So for example, you can define limit 100, and that's called a macro. So it's a macro definition. And this is very powerful, but it's also very, very dangerous, because what you're doing here is you're saying anytime I put this limit keyword in my code, the preprocessor will literally go through all the code and do a find and replace on limit and replace it with 100. So you can be really sneaky with some people's assignments if you want to play a prank on them and define 1, 0. Or define true, false. Like it's very, very bad to do that sort of thing, but it can be done. So you can see how that sort of thing would be really powerful, but really dangerous. So what the include keyword does is it actually inserts the file into this file. So if we typed include myObject.h, that will quite literally take the entire text from the file myObject.h and put it right where you said include myObject.h. Okay? So that's what we have. This is the whole process that we just saw. So the separation of CPP and H files, we will actually show an example of this in the next class when we show the assignment files that I give out. But C++ class code is often separated into two different files. So the .h file, or the header file with all of the declarations, and the .cpp file, or the implementation file with all the definitions. What is a declaration? A declaration is a line of code that declares that a function exists. So it has the name of the function, it has the return type of the function, and the arguments of the function. But it doesn't actually include the code that the function calls. That's where the definition comes in. So the definition of a function is different from a declaration in that it also includes the actual code that the function runs. And we'll see why that matters in the live coding. So a header file will contain class function declarations. So declarations include the function name, the return type, the arguments, etc. That's required by C++ to see all of the declarations of classes, functions, and variables before use, and we'll see an actual example of why that matters. And they serve several useful purposes also beyond the required calculation. So let's look at an example of that now. So let's say that I have a function, okay? So my function, void my function, this appears somewhere in my code, okay? It doesn't matter where it appears. Inside that class, I have my class I'm going to declare a variable of type my class. So I'm going to say my class C, and that will set up a new object, my class, and then we're going to call a function on that object, okay? So somewhere I have to have defined or declared this my class function, right? However, in C++ and in C, I cannot define or declare the class after, in the file, where I use it, okay? So the C++ compiler goes from top to bottom through the file. And so it's going from top to bottom, top to bottom, top to bottom, and it says, hey, here's my class. I haven't seen that yet. And if it hasn't seen it yet, it can't compile. And so you can't include the code for my class down here. It actually has to go above it in the file. And so what header files are usually used for is exactly this, okay? So what you do is you're going to declare your my class structure, so what it actually looks like, what the functionality is, what it does, what variables it has, and you can either include that whole piece of code up here before my function, or you can use the preprocessor. You can write the declaration in myClass.h and then just say include myClass.h. So that's what include actually does, is it tells the preprocessor, hey, go look at myClass.h, that whole file, copy that file, and insert it right here. And because we've inserted it there, now this function knows what myClass actually does and it can use it. Okay, so that's what includes and the preprocessor actually does. So what are some benefits of header files? This is just an example of a header file that I used in another course of a vector class that I made, or a vec2 class. So what it can do is actually it's really nice because it can allow you to see all of the functionality of a class at once. Because in the header file, you just have the declaration. So see here, you just have like vec2 operator plus, or the plus equals operator, or the equality operator, or the variables. It doesn't actually have the implementation code. So you can see all the functionality of a class just at a glance by looking at the header file. And it also does something neat, which is it separates the design of the class from the functionality of the class. Yeah, it separates the design of a class from the implementation of that design. And that's really nice because here I can see the design of the class, but I may not necessarily want to know how those things are implemented. I just want to know, hey, how do I use that class? What are the function names? And also, header files really seldom change. And so, you know, maybe I improve the implementation of this at some point, but it's not very likely that I'm going to be adding functionality to and from a class all the time. And so less files are going to need to be recompiled if we have these sort of static header files. What are some drawbacks, however, of header files? You have more files in your code base, right? More files sucks. It's more files to deal with. It's more headache. If you have header files and CPP files, maybe now you have to tab back and forth between the header files and the CPP files, and that may be a little bit annoying. Cyclic dependencies can be hard to detect and resolve. We're not going to get into cyclic dependencies here, but if you ever run into that, header files can actually help solve that. So again, a little bit of a diagram here. We're going to have our source files, so CPP or HPP files, they get compiled into object files and they all get linked together. Okay, so I don't need to go over that. We've talked about that already. C++ primitive types. We've got lots of primitive types in C++. We've got char, short, long, int, float, double, long, double, bool, all sorts of things that you're familiar with from languages like Java. We've got arithmetic operators, so we've got addition, subtraction, multiplication, pre-increment, post-increment. We've got bitwise operator as well, so you can just use this as a resource. I'm not going to explain all of those. Functions are very, very similar to Java. We've got a return type, a function name, an argument list with types, and also the logic. We can have the same function name with different input arguments, but you can't have functions with the same name and arguments that differ only in the return type, okay? So that means that I can have two functions with the same name as long as their arguments are different. But I can't have two functions with the same name and arguments that only differ by return type. That's just specific to the language. C++ classes are really easy. Let's say I wanted to make a class point. Well, this is the syntax for that. It's very similar to Java's class structure. So we can have private variables and public variables. By default, if you declare something as public, it will be public, but if you do not declare it, then it will be private. So here we've declared class point, then we start declaring member variables. Since they haven't been declared as anything else, they are by default private. Okay. In this course, I'm going to be using the m_ naming prefix to say that something is a private member variable. So if you see m_, that means it's a private member variable in this course. So down here, what I've done is I've declared a public constructor. So a point constructor would take in an x and a y, and then probably set them somehow. We may also have functions get x and get y, etc. So the actual constructor that we would define in the .cpp file would look like this. This is the point constructor. It's a part of the point class. So before, where we had namespaces using : the same thing is true of classes. So we say the point class : has a constructor that's called point. It takes in an x and a y, and we set the internal variables mx to x and my to y. However, in C++, we actually have something different than in Java, which is called an initializer list. And I'm actually going to get into that in the live code, so I won't explain that here. The destructor is always called tilde with the class name, and you do any cleanup here that you need to in the destructor. We also have some STL containers. So for example, we have standard vector of a type. Okay, so if you have like a standard vector of ints, or a standard vector of doubles, or a standard vector of my class, this is very similar to how Java does it. We could also have a set, or we could have a map from one type to another type. Some functionality that we might use on a vector, and you can look this all up online. So if we have, for example, a vector of ints called vec, what we could do is we could use the vector constructor to say, I want some number with some values in there. So we could say, for example, standard vector int vec, I want 100 threes. So that vector would be initialized with 100 members, and they would all be equal to 3. If I want to add a single thing to a vector, I can say push back. Okay, what is it in Java? .add. In C++, it's .pushback. If you want to remove from the back, it's pop. If you want to clear everything, it's clear. If you want to set the capacity of a vector so it doesn't resize, that's reserve. However, accessing things in a vector has the same syntax as an array, which is really good. Okay, so we don't have to say vector.get like in Java. We just say vec I equals value, for example. And what I'm going to do now is I'm actually going to switch to the live coding, because I'm going to give the examples of these in the live coding session. So let's get to the live coding. And this lecture is going to run a little bit long, okay? It's going to run a little bit long because I want to make sure that you understand the syntax and of the basic C++ functionality that we're going to use. So if you have to go before the lecture's over, I completely understand. The video will be put on the playlist, so that doesn't really matter. That's one of the reasons I love online courses, because if you have to go a little bit over time, there's not 50 students putting on their backpacks and stuff like that. Alrighty, so let's get into my terminal programming scene. And all right, so what we're going to do is we're going to make a program in C++ that shows off all the functionality that we just talked about. So I'm going to use Vim for that, and we're just going to call this program test.cpp. All right, so now I have my text editor open. It's a blank file, and we're going to start programming some C++. Okie doke. So the first thing we're going to do, as we did before, is we're going to include IOStream, right? That's the preprocessor directive that includes the IOStream library, so we can actually print things to the console. So next, we have our int main function. So this is int argc, that's the number of arguments we want to pass in. And we have char star argv, that's the array of strings that's going to be passed in. First thing we always do is we're going to return 0 if the program finishes correctly. And then in this program, we're going to standard cout hello world. Okay, so let me write that file and quit. And so if I say cat to c test.cpp, that's the file that we just wrote. Okay, now I want to compile that program. So I'm going to say g++ test.cpp, and I want to specify an output file. So I'll say -o test. All right, so there were no errors in the compilation process. So I'll say ./test, it'll run the file, and it'll say hello world. Okay, so that is going to get really cumbersome if I have to type that every time. But what I'm going to do is inside Vim, because Vim is a wonderful text editor, I can actually just hit my hotkey here. It will compile the program, and if there's no errors, it'll run it for me. Okay, so I have a magic hotkey that does that, and I can share that with all of you later if I want. So let's say here, I'm going to make some errors and see what the errors look like. So for example, if I said SSTD instead of standard, and then I try and run it, I should hopefully get an error. Okay, so the error here says test.cpp in function int main on line 6, error, SSTD has not been declared. SSTD cout see hello world. So that's a great error message. That actually is really, really helpful. So if it's not declared, then I can change it to what it was, right? Okay, perfect. Down here, for example, if I changed this variable to something that doesn't exist, then it'll tell me that, okay, std, that standard library exists, but the vcout is not a member of standard, okay? And so it tries to tell me maybe something that looks like it, but in this case, it's not correct. So let me change this to bout and see what it says. Yeah, so for example, the compiler here got it right and said, suggested alternative cout. So C++ compiler errors for really simple examples are fine, right? Okay, let's do some basic variables now. Actually, before I do that, some people I've seen in the chat have talked about this line. So you can say using namespace std. And what that will do is that you can actually remove this standard namespace call that you were manually calling before, and now you can compile and run your program as normal. So what happens here is that if you say using namespace and then some namespace name, so here we're using standard, if you call a function or variable that doesn't exist in your program, it will go through this namespace that you've said we're using that namespace, and it will find it and it will apply it. Now, a lot of people like using that because it's less typing. I do not like using that because it can lead to weird stuff if it's used in the wrong place. Okay, so we're gonna manually declare standard cout for the entirety of the course, and you won't be using standard a ton, so it's not going to be a lot more typing. So that's just a quick note on using namespace standard and why I don't use it in this course. It is another religious debate on whether or not you use that, but we're just not going to use it. Okay, so let's look at some integer addition. So int a equals 42, int b equals 600. Okay, I can say int c equals a plus b. All of this is really basic stuff. But if I want to now, I can print that out and say standard cout the sum of a and b is, and then I can just pipe c in there like that, and this should hopefully work. Okay, so the sum of a and b is 642. Done. So that's just statically typed things. It's normal, just like Java. We can have a double here, pi equals 3.14, etc. Okay. Let's look at strings a little bit. So the weird thing here is that for some reason, some versions of C++ and some compilers need you to include string when working with strings. This version on this operating system, you only have to use IOStream in order to use string, but let's just put string in there just in case. Okay, so let's look at standard string. So standard string, let's say I have my name equals Dave. Okay, so I'm going to say this is first name, Dave, and standard string last name equals Churchill. So if I want to have something like standard string full name, then I can say this is first name plus a space plus last name. Okay? Now down here, if I go and delete this, I can say full name is, and then full name, oops, and then a Newline character. Perfect. Okay, so that's how we use strings. They're really easy. They're kind of like Java. Here, something that I will note is that C++ and Newline characters are a bit interesting. So Newline characters between operating systems can differ. So for example, in Unix-based or Linux-based operating systems, /n is the universal Newline character. However, if you open up a file that has a bunch of /n newlines in Windows Notepad, there will be no newlines. And that's because in Windows, the Newline character is this carriage return /r/n bullshit that has caused me unknown amount of time and frustration in my life of C++ programming. So, if you want to be completely awesome, you can say this is the standard endline character. And what standard endline will do is it looks up your specific operating system's Newline character and inserts that, okay? So that's standard endline, but it's a bit much for me to type that every single time. And since this is connecting to a Linux system, then I'm going to be using /n for my Newline characters. Okie doke. All right, so now let's have a little function. Let's write a function. So my function is just going to return an int, and I'm going to have a function which is awesome called get10, okay? And that get10 function is going to return 10. So down here, I'm going to say function returned, and then I'm going to say get10, and then a new line. And so let's run that. That operates as you would normally think, right? You take this function, you call it, and it returns the value that you thought it would. Now, however, let me take that function and demonstrate what we were talking about in the class, right? So if I run this now, if I try and compile it, what will it say? All right. So it'll say CPP line 11, character 46, error, get10 was not declared in this scope. Oh, what does that mean? Well, the compiler went down from the first line of code, compiling, and then it got to here. And it said, what is get10? I don't know what get10 is. Immediately stop, crash, not crash, but immediately stop compiling. This person's an idiot. Why? Because they put it below instead of on top, right? So some programming languages care if it's on top. Some programming languages don't. C++ is a language that cares. So up here, what we're going to do is we're going to solve that by declaring the get10 function. So I'm going to say up here, int get10, boom. All right. So this is called a declaration. It contains the return type, the function name, and the arguments. There are no arguments here, but it doesn't have to have the implementation, right? So it doesn't have to have the definition yet, but C++ now knows that when I call get10, it's going to be a function that exists somewhere, okay, in my code, doesn't matter where, but it will return an int, and it takes in these arguments, and that's what it really cares about. So now if I run this, it's gonna be fine. So the whole reason we use includes is let's just pretend that we had a file that contained that code. Then we could include what was it called? get10.h right there, and it would take all of the code, all of the text from the get10.h file and just insert it right here. And that's literally what it would do, okay? So that's how functions work, and we don't need to go into any more detail of that because pretty much everything else, they're going to be the same as Java. Okay. Now, let's do something more interesting. Let's make a class. We're in a class, right? Let's make a class for our class. So let's say course. We've got a bunch of students in this course. So let's make a student class and store some data in it and modify that data and play with it in interesting ways, okay? And the reason that I'm doing this is because I want you to get used to C++ classes, see how easy they are, and how great they can be. So the syntax for that is we're going to make class student. In C++, you have to have a semicolon after the declaration of your class. So I'm going to have some public things in here, and I'm going to have some private things in here. So here's how, now white space doesn't matter, things like that. Some people like to declare public things first and then manually declare private things second. I'm a big fan of doing it this way, where you have your class, your private class variables first, and then your public things later, okay? So here, what are some things that a student could have? Well, let's just say we're going to have a standard string, first name. We're just going to call that first for now because it's going to get pretty long in a single line later. Then we're going to have a standard string mLast. Then maybe we're going to have an int, which is mID. So we might have a student ID number. And then we're going to have int mGrades, or grade, okay? So that's going to be what a student is going to hold. Now down here, of course, we're going to need a constructor. So that constructor is going to take in, let's just have it take in all the things that are within the student, okay? So here we're going to have a standard string first, standard string last, int ID, and int grade. Okie dokie. So this is what our student class is going to do. And now, I know some of you out there have already spotted an inefficiency in the program that I'm writing. If you see what I could be doing better here, please tell me in the chat, but I will get back to it, okay? So the way that I would set those variables is we could have like m first equals first, and then m last equals last, then mID equals ID, and mGrade equals grade, right? Just like a Java program. And this will actually compile and run. So, alrighty. Down here now, what I'm going to do is I'm going to create a student. So I'm going to have a stack allocated student, okay? And if you want to know the difference between heap memory, heap allocation, stack allocation, I've included a link to a lecture that I did in a previous course on that, just so I don't have to take too many out of that. So we're going to make a student S1, and we're going to pass in Dave. We're going to pass in Churchill. We're going to pass in, what's my student ID? Let's say 2001, because that was the year I actually started my undergrad at Memorial. Oh my God, it's 20 years ago. Oh God, I started at university 20 years ago. That's crazy. And my grade obviously is 10,000, right? It's got to be 10,000. So let's see if this compiles. Oh, it compiled, but it didn't do anything, right? So what we want to do now is somehow print something of the student. But all of these things up here, these are all private variables. So I've got to have some public facing way to get that. So let's have something like get name, okay? So we're going to return a string, and this is get full name. And what we can do here is we can return m first plus a space plus m second, right? So that will construct a new string and return it. Maybe for efficiency purposes, if we wanted to store the full name, we could do that. But for now, we're just going to do this. Next, what we're going to do is we're going to have a function which returns an int, which is getID. And this is going to, for sake of space on the screen, this is going to return MID, and I'm going to write that all on one line. And I'm going to have getGrade, which also returns mgrade on the same line. Okay. So let's compile that and see if that works. Okay. Oh, M second. That's M last. That was a test, and you all failed. You should have reminded me that it was M last, right? Okie doke. So now let's print out something about a student. So we'll say cout s1.getFullName, and then a space, and then s1. Let's just say getID. And then we'll print out a new line. I could print out the grade as well, but I wanted to thank you for that. See, someone out there is paying attention. I could print out the grade as well. I just want it to be all on one line. So let's run this code, see if it runs. Oh, look at that. Dave Churchill, 2001. Perfect. Exactly what I wanted. Now, what I could also do is have a function up here, which is like standard standard string. And let's say our function, or our student, is going to have a toString function. So what I could do in the toString function is return a string, which is... no, I won't do that for now. Let's just leave it as it is, because that gets into a little bit more annoying stuff. Okay. Now, something that I said was a little bit inefficient about this. Let's say that we want our student ID to always be constant for a student, right? So we can never, ever, ever change a student ID. So we can do that by typing const in front of this. Now, let's say that our name is also going to be const, okay? Now, I know in real life you can change your name, but let's just say at this school, our names, our grade could change, but our names and our student ID can't. So let me try and compile this now. Uh-oh. I've got a bunch of crazy error messages. Yeah, so this is where C++ gets a little bit wonky. But what it's basically telling me is that I am trying to set a variable which is const. Right? So I'm taking m first and overwriting it, but it's const. So how could I possibly do that? Well, good thing is there's a solution for that, and that solution is actually helps us in other ways too. That solution is called an initializer list. And here's the syntax for an initializer list. We're going to put a colon after the function for our constructor. Then we put a variable name, and then in brackets we put the value. So this says initialize the value of first, m first, with first. Then, now it doesn't have to be on a different line, but I'm just putting it on a different line. Last gets the value of last. MID gets the value of ID. And mgrade gets the value of grade. Okay? So, initializer lists do two things for us. First of all, what it does is it eliminates the duplication of copying things. So what initially happened here, without the initializer list, when my student object was created, all of these objects up here, these variables, were given values. Okay? They were given values, and then those values were overwritten down here. If you think, if this is like a class that has a big constructor or something like that, we wouldn't want to have it construct once and then construct a second time. And so by doing an initializer list, that passes the arguments that are input directly into this constructor, so it's only ever constructed once, which is a huge time savings. And not only that, but it allows us to set initial values of const member variables. So this should work. All right, perfect. So that's what initializer lists are. You're going to see them in our code, and that's why they're used. Now, something else that is important is that in C++, variables are passed by value. Okay, they're not passed by reference. If you're used to Java, then Java actually is more object-oriented. It has capital objects for every type, right? So if you pass something in, it's going to be passed by reference. In C++, they are passed by value, okay? So, for example, and I have examples of that in the lecture video that I gave out. So I'm not going to get too into that, but what I will do is say, if you ever see this symbol, this is a reference. And so what this does is it says pass what's essentially a safe pointer to this, into this function, okay? And if we want those to be const, then they can be const. So we'd say a const pointer. This stuff is going to be on the next lecture. But if you ever see a const type reference to something, that's how we prefer to pass objects that are larger than just base type sizes. So that's one other thing that we could do to make this a little bit nicer. But for now, I'm just going to leave in pass by value, which copies the string, which is a little bit not exactly what we want to happen, but that's fine. Okay, so that's what a class is, and that's what it's used for, right? It's a really simple syntax. It's really easy to use, and what we've done so far is almost all the functionality we're going to need in the course. The only other functionality that we're really going to need is containers, right? And so the container that we're going to use most often is a vector. So let's look at include vector. So a vector, just like the vector in Java and in many other programming languages, is essentially just a dynamically sized array that we can keep adding stuff to or delete things from. Okay. So let's give an example of what a vector can do. And we're going to do this by creating two students. So let's say student 2 is my middle name and my last name. And then they started in 2002 and their grade is 20,000, right? Now what I want to do is I want to add those to a vector. So I'm going to have a standard vector of students this time. Okay, so I've got a student class. We've got to say, hey, vector class, you are going to be storing students. This is going to be students. Okay, then in students, I can push back S1, and I can students.push back S2. Okay, perfect. There's an extra I on the last 9. Oh, thank you very much. Perfect. So let's just see if that code compiles. Excellent. So that code compiles. Now what we're going to do is we're going to change this so it's going to be reading it from the vector. So this is going to be students 1 or 0, and we have we have the same functionality there. Okay, so students 0.get full name, students 0.get ID, and students 0.get grade. All right, let's see if that works. Perfect. Oh, I wanted a space here. Okie dokie. Now, so it turns out the only people watching this right now are people who know C++ anyway, which is awesome, but the VOD is going to be there for the students that don't, right? So now we're reading it from the vector. So if I want to get the first thing in the vector, I call element 0. If I want to get the second thing, I call element 1, etc., etc. But what we actually want to do is iterate through the vector, right? We don't want to be calling like each one individually. We want to do this as a group. So let's delete all that. And what we're going to do is I'm going to show you the two major ways that we're going to be iterating through collections in this course. So the first way, which I'm sure you're used to, is just for int I equals 0, I less than students dot size, I plus plus. Right? And now we can say standard cout students I dot get full name, and then we can do this. So what this will do is just like an array in any other, just like an array or vector in any other language, we can just iterate through using indices. And it has told me, okay, here's a warning. Comparison of integer expressions of different signedness, int and size type. So what this has told me is that I am comparing the return value of students.size to an integer, which is a signed type. But here, int is signed, so I can change this to a size t or a size type, which is essentially a long unsigned integer. So that will get rid of the warning, and then this will go through and it will print all of the names of all the students. The other way that we could have done this is with a range-based for loop. So we could say for each student, and we want to have a reference here so it doesn't copy it. So for each student s in students, standard cout s.getFullName. And this is a bit more of a modern way to iterate through a vector, right? So this will work too. I printed them out once using the first way, printed them out second using the second way. There are other ways to iterate through these. We could use like C++ iterators, which I'm not even going to get into because I don't need to. But this is how we would put things into an array and then how we would get them from an array. Okay, so now we've got a vector of students. And the last thing I want to do is let's really clean this up, and we'll say, okay, what I want to do is actually have a course. The course is going to be an object, right? It's going to be a class, and that course is going to store students. And what I want to do is instead of manually inputting this stuff, let's actually grab the information from a file, put it into a student object, and then add that student to a course somehow. And then once we've done that, we've essentially covered all the C++ that we're going to need for this course in terms of functionality. Okay, so rather than take this student class and put it into a student.h file, let's just leave it all here for now. And what I'm going to do is create another class called course. And I'm going to have a public constructor. So this is going to be a course. And let's just say for now that the course will I guess this course is going to have a string name. So const standard string name for the course. Okay, so this course is going to have a name, right? Standard string m name. And it's also going to have a collection of students. So what we're going to have here is a standard vector of students, and we'll call that m students. All right, do we need anything else? I think we're good with just that. For now, at least. Let's see if we run into anything else. So one thing we might want to do for a course is say add a student, right? So I can add a student to this course, and I can say student, and this student will be added to the course. How do I add that student to a course? Well, I would say mstudents dot push back student, right? So that would add a student to the course. So now let's go down here, and instead of manually having a vector of students that we're iterating through, let's create a course object. So now I've got a course. I'm going to call that COMP4303. That's the course. And now I'm going to say COMP4303 dot push or dot add student S1 and COMP4303 dot add student S2. Okay, perfect. But now I need some way to get at my students, right? So let's see how I would get at the students. Well, what I want to do is I want to return this collection of students somehow, but I don't want to be able to modify that, Okay, so again, we're going to use the const keyword to say that I'm going to be returning a reference to this vector, but that's going to be a const reference. So I'll say const standard vector student reference get students. All right. And now I'm going to say return m students. So now down here, if I want to actually iterate through the course, I can say for auto, or, oh yeah, here's another thing. I could say for const student reference s in COMP4303 dot get students. Uh-oh. Lots of typing here. And then I can say, now I've got that student S, I can standard cout s.get full name. All right. Now let's compile it. Uh-oh. What did I do? Oh, I forgot to put in the constructor name, which is COMP4303. Okay, perfect. So that was a missing constructor variable. So here, const student as this argument, okay. Okay, here's another thing about const and const correctness, and this is annoying. We're not going to get into this too much in the course, but I want to explain it now because you will probably see this at some point in the future. So I've got a student here. This get students function returns a const vector reference. So that means that all of the students inside that vector are going to be considered as const objects, which means that they should not be able to be modified. However, what I've done here is I've called a function which is get full name on that student object. Who knows? Maybe that get full name function modifies the student somehow. So if I'm dealing with const student objects and I'm calling a function which might modify them, then that's a problem. However, there is a way to fix this, and that's by doing the following. So if you know that the function will never modify the object, you can put const at the end of the function name. And by doing that, you can now call that function on a const object. So now that I've put const in there, this will work no problem. So that's something that you'll probably run into, and this is called const correctness. It's const correctness because it is correct to always declare a function, a member function, as const if it will not modify the calling object, and that's why. So that's how we would create a course and add students to it. However, let's do something like the following. So let's open up a file, and the file is going to have some students in it, okay? So we're going to have a bunch of data in this course that we're reading in from files, and I want you to know how to do that. And so here's the tutorial on file reading in C++. And after that, I know I've gone over time, will be about another 10 minutes, another 10 minutes, but you'll know how to read from files. So here's the file. What I'm going to want to do is go through this file and get all the data and add those students in the course. So here, separated by spaces, I have first name, last name, student ID, and I have the grade at the end. So what we're going to do is we're going to load back up test.cpp, okay, and we're going to add that functionality. So let's say that I'm going to want to be able to add students to the course from a file. So let's write a function, add from file, and then that's going to pass in a file name, okay? So we're going to be able to add the students that are listed in this file from within this from within this function. One thing that I need to do is we're going to be using file streams for this. So I'm going to include the fstream library because fstream is file streams. So input stuff from file, super easy. Standard ifstream fin for file in. This is just a variable name. It could be anything, but we're going to call this fin. And we construct our input file stream, so if stream, called fin, based on the name. That's it. One line of code, few characters. We've got it set up already. Now what we can do is we can start just reading from the file. That's actually really cool. Let me show you first how we read variables from the file. If I want to get variables from a stream in C++, so let's just look before. When I wanted to put variables into a stream, right? When I wanted to send variables into cout, I could just say put 12 into there or put hello into there, okay? In the opposite of that, if I want to take data from a stream and put it into a variable, I use the opposite pipe. So let me just show you how I do that. So I'm going to be reading strings in from here. So what I want to be able to do is read in some strings, read in some ints. So I'm going to create a standard string, which is a temp variable. Actually, let's say what we're going to be reading in. So this is going to be the first, and I'm also going to create a standard string last, and then I'm going to have an int ID, and I'm also going. Oh, let me show you this too. We could also do a comma and say grade. Okay. So if I want to start reading in things from the file, it's super easy to do that in C++. If I want to get the first string from the file, and I know that's going to be the first name of somebody, then I can say fin first. Okay, now let's just try printing that out. Okay, so that's what we're doing here. And what did I just do? Oh, I put that all in the wrong function. My apologies. So this is what? 7 lines. I'm going to take this and I'm going to put it in add from file. Okay, this is where I wanted this to be, not in the constructor. So here, now down here, if I say COMP4303.add from file, and I've already got that file created, students.txt, then what it's going to do is it's going to read that, and it should print out, okay, this is file name, not name. Oops, another typo. Here we go. File name was not declared in this scope. File name, man, I can't spell at all, wow. Perfect, okay. So, someone just asked, standard string first, last, is it valid? Yes, so we could do this as well. If we want to set up 2 variables like that, we can do that. And so we've called that function. I'm going to print out something here, standard cout starting file read, and then this is going to be like that. So let's see what happens when I call this now. Okay, so we said starting file read, and then we read the first name from the file. So it was that easy to get a string from the file, right? So if I go back and I look at the students.txt file, if I say fin pipe into a string variable, it's going to read this. If I do it again, it's going to read another string. If I do it again, it's going to read an int. And if I do it again, it's going to read that int. So let's look at this. Oops. And let's try to read the entire student from a file. Okay. So how will I do that? Well, I'll say fin first, fin last. Now I know the next thing. Now I'm assuming my file is correctly formatted, right? So if I'm reading in an integer, what's there has to be an integer or you'll get an issue. Then what I could do is I could construct a student S, and I can pass in first, last, ID, grade, okay? And then I could print out that student. So actually what I'm gonna do up here, if I wanna print out a student, let me do a void print function on a student, which will make things easier for me coming up in a second. So if we wanna print out a student, we're going to standard cout get full, well, I can actually just do this, m first, m last, nope, m ID, m grade. Okay, now I can print a student. And now I can say, okay, now that I've constructed that student, let's s.print. Okie dokie. So let's do that, see if it works. Okay, MID was not declared in this scope because I had a typo up here. That is a capital ID. Apologies. Okay, so what it did is it said starting file read. I read in the first name, the last name, the ID, and the grade, constructed a student object, and then printed that student object. So let's go down to where we were before, and we're going to get rid of this that we did. And I'm just going to create a course, and I'm going to add all the students from the file. Okay, so we're going to keep going. Now, you could do this in a way where you keep reading different lines from the file. And so you say get line, and then you could construct a stream, like a stream based on that line. But since we know the format of our file, so if I open that up again, oh, I have the save. Now, if we look at the file, if I use the piping operator again, it's just going to go to the next line because the pipe operator skips blank spaces. So it's going to skip spaces and it's going to skip new lines. So if I say give me the next name, it's just going to go right to the next variable, which is on the next line. As such, we don't need to use like the get line command. So if I want to read in things until there are no more things to read, luckily for us, this fin first, fin last, if there was nothing there to read, it will return false. So what I can do cleverly is something like this. While fin first, okay? And what that will do is it will try to read another first name from the file. If there is one, it will return true and put this into the first variable. So this loop will exit when it reaches the end of file. So all I've got to do in here is say fin last, fin ID, fin grade. And now I've read everything that I wanted to. Now let's construct that student up here, right? So I've got a student now. I'm going to get rid of this. And once I have that student constructed with all of that data, I'm going to say add student s, right? Because that's in the class. The add student function is already in the course class. So now down here, the last thing that I want to do is iterate through all the students in the course and print them. So I can easily say for const student s in COMP4303 .get students. Now I've got s.print because I made a print thing, a print function on the students. Okay. Oh, but what I didn't do was make it const correct. And so I didn't put in const here. And so now this should work. Hey, look at that. That's really cool. So I've read in all of the, I started the file reading, I read in the data from the file, I constructed a student from that, and I added that to the course. And then later, what I did was I printed out the data from all the students, okay? So we've encapsulated that nicely within the objects, and so that's what we're going to be doing for this course. One last thing that I wanted to show you is that we didn't need to do this up here where we create a variable first and then add a student. If we wanted to, we could actually create the student in the function call. First, last, ID, grade. And then we could do the same thing, and then this would work, okay? So we can eliminate a lot of those temporary variables, and not only that, but this is also a really cool shortcut, is that we don't need to make all of these separate piping calls, because this, if we look at this operator, what it actually returns for us is a reference to the stream at the point where that has been done. And so what we can actually do here is this. And so it says fin, the last name, the ID, the grade. And then that should work as well. Done. Look at that. Isn't that crazy? That's really cool. Actually, I'm not sure if this will work or not, but I want to see if this will work. Last ID grade, and then we'll comment this out. I've never tried this, so if it doesn't work, wow, that worked too, okay? So that's really cool. So this is like, it's so easy to do really simple file reading in C++. And this, I would say that you can't do this in fewer lines in Java, maybe even Python, right? Like, it's really easy to write really safe, really fast code in modern C++. And that's it. That's all I have to say about C++ right now. If you want to learn more about that, you can see the lectures that I've posted on D2L. Someone said if you are missing an element in the last line, then it would fail, I think. Well, let's try it out. So what we're going to do, oh, there's a change. Oops. So let's write. We'll open up the students file. And someone said, if I'm missing one of the elements here, so let's say Joe Blow 3, or let's just stop it at Joe Blow, right? Then we'll write that out. We'll go back to test.cpp. And now we'll compile and we'll see what happens there. No, it worked. And the reason it worked, I think, is the following. Because it tried to get first, it got it. It tried to get last, and it got it. And then it tried to get ID, and then it returned false. And so it stopped there, right? So that's what I think happened anyway. And so it didn't add the student because of that. Cool. So I want to go back really quickly to this view. So this, again, is the course spreadsheet. And that was the intro to C++. Again, if you want to know more about C++ or about SFML, what you can do is go to the COMP4303 playlist. There is an entirely other lecture on C++ which talks about memory, stack and heap, and pointers. Okay, so if you've never done C++ before, please go watch that lecture. And then, if you want to do custom stuff with your SFML later in the class, or for your project, then you can watch the next lecture, which is the Intro to SFML. But I didn't want to take up too much time in this course talking about that, and so those lectures are available for you online. And for anyone in the chat, if you want to watch my other courses, you can do that for free. All of those lectures are available online. So next lecture is really important. First, we're going to go over some 2D mathematics that you'll need for the course. I'll be going over assignment 1 and the assignment structure, as well as how to use Visual Studio, and that will be how we're going to do all the assignments for the rest of the course going forward. So once we introduce assignment 1 and Visual Studio, all of the other assignments will be given out with the Visual Studio project in the exact same way. So we'll only need to introduce Visual Studio once and sort of the overall structure of the assignment once. Okay, so since it is Thursday, by the look of things, this will be given out on Tuesday, and you will have 2 weeks to complete that assignment. So thank you all for tuning in to this lecture, and I'll see you on the next one.